This is Algebra 2 with trig. We're working on 2b.4, the composition of polynomials. The composition of a function g with a function f is f of g of x. This is a different notation than we're used to. We're used to it being f of 4 or f of x. Now we have f of another function. Instead of just substituting a value for the x, we're going to substitute an expression in for x. So here, we're going to take a look at the f function. The f function is 6x, so 6 times something plus 2. So that is the outside letter, it's the f. So we write down the f, but without any x's involved. And then we're going to plug the g into that. So we're going to plug the g function into the parentheses, replacing what used to be the x. You would probably plug it right into that line, but I just want to show you that it's almost two different thoughts. First you have your 6 times something plus 2, then you plug your g function inside the parentheses. Then you just go ahead and simplify it. So this is 18x plus 30, so 18x plus 32. That is your f of g of x. Now we've got g of f of x. So we're going to take our g function, which is 3 times something plus 5, and we're going to plug our f function to the inside of that. So our f function is 6x plus 2. Then we can distribute through, and that's 18x plus 30. So notice how they're different. In this case they're relatively close, but they are different. So f of g of x and g of f of x are not the same. They do not always give you the same value. So now you can pause the video and try f of x. Your f function is 6 times something plus 2. And inside that something, inside of the x, you're going to plug the f function, which is 6x plus 2. And then you can collect your like terms to get 36x plus 14. Now notice this is g of 4. So we're going to take the 4 and plug it in. There's two different ways we can do this. We can first work with the g function and plug the g inside of it, which is 3 times 4 plus 5. So we know that is 12 plus 5 to get 17. That's this middle portion. Then we're going to plug that into the g function. Happens to be the same function again. So this is 3 times 17, which is 51, plus 5. That gives us an answer of 56. So this equals 56. Well, the other way to do it, sometimes it seems a little bit bigger. If you've already done the calculation, it really helps to do the g of x first. So g of x is taking your 3 times 3x plus 5, plug in your g function inside your g function, and that's going to give you 9x plus 15 plus 5. That is your g of x. So then we're going to do g of 4. So 9 times 4 plus 20 is 36 plus 20, which is 56. You're going to get the same answer. You got two different methods you can do it. Here, we're going to purchase a pair of water skis for a price tag of $180. The sports store applies a newspaper coupon for $50 and a 10% store discount. So the composition, or use composition, to find the final price of the purchase when a coupon is applied before the discount. So we're going to take the $180, we're going to minus the coupon. The coupon was for $50. We're going to apply the coupon first, which gives us $130, and then we're going to apply the discount, which with the discount we get 10% off. Well, to take 10% off the whole price, you're actually paying 90%. So if you think about 10%, you move the decimal spot over 1, you got 13, so you're taking $13 off of this. $13 off of this would be $117. So if you had a function called x minus 50 and a g function of 90% of your price, what we have done here, we have done this calculation first. So we're doing g of f of x. We're doing 90% of taking $50 off. So in this case, we're going to do the discount price before the coupon. So you take your 180 and we're going to apply the discount, which is 10%. So 10% of 180 is 18. So we get 162. And then from the 162 we take our $50 off and we get 112. So you notice the prices are actually different. If we're still working with our two functions, now we're doing f of g of x. We are taking 90%, 0.9 or 0.90, whichever you like, times x minus 50. In our case, that gives us 112. Alright. Flip side. These are still our notes. Alright, these are just practicing the same problems. So if you've got it, then pause the video, give it a try, and then you can watch the video to see how you did. So we're going to take the f function, which is 5 times something minus 4. Then you can take the g function, and you're going to plug it inside the parentheses. The only thing we can do here is distribute the 5 into that. So this is f of g of x. G of f of x. Well, you start with the g function, which is x. That's x. Don't put down an x. Cubed. Then you put the f function inside of that. The f function is 5x minus 4. Now, the big question is, how do you cube this? So go ahead, pause the video, cube this, and then turn it back on. to cube this, you're going to not distribute. This is not 125x cubed plus 64 or minus 64. You can't do that. You have to write it three different times. You're cubing it. Then from here, we will FOIL that together. So we get 25x squared minus 20x minus another 20x plus 16. And you bring down your 5x minus 4 that you haven't used yet. So we'll collect our like terms. 20x and 20x is 40x. With your 5x minus 4. Then you distribute, which is 125x cubed minus 200x squared, x and x is x squared, plus 80x. And then you do the 4, which is negative 100x squared plus 160x minus 64. So that leaves us with the final 125x cubed minus 300x squared. 200 and 100 is 300. 240 x's minus 64. That is g of f of x for these expressions. F of h. So the f function is 5 times something minus 4, and we're going to put the h function inside of that. So we're going to put the x squared minus 2x plus 7 inside of the parentheses. We would distribute through and then subtract the 4 at the end. That is f of h of x. Now let's try h of f of x. Well, you take the h, which is x being squared, minus 2 times x plus 7. You put your f function inside of that. So we have 5x minus 4 that's being squared, 2 times 5x minus 4 plus 7. So we're going to square this, which means write it twice. Distribute this through to get negative 10x plus 8. Then your 7 at the end. FOIL this together. We get 25x squared. A 20 and 20 makes negative 40x plus 16. That's a perfect square trinomial. You're squaring a binomial. Minus 10x plus 15. 8 and 7 is 15. Then our final is to collect our like terms. Negative 50x plus 31. That is h of f of x. We're going to evaluate what g of f of 2 is. So you could take your function of g of f of x and plug it in here. You know that g of f of x from letter b above is 125x cubed minus 300x squared plus 240x minus 64. That came from the problem above. Now, if you want to do g of f of 2, you could plug a 2 in for every x value. So this gets pretty big, working it out. So here we have 8, because it's 2 cubed. It's not 125 times 2, it's 2 cubed, which is 8. And 8 times 125, that's 1,000. 2 squared. So you have 1,000 minus 1,200 plus 480 minus 64. That gives you 216. That seems like a pretty good way to do it. Or you could have figured out f of 2, which is 5 times 2 minus 4, which is 10 minus 4, which equals 6. And then you could have plugged that into your g function. G of 6 is 6 cubed, which is 216. So often this is a lot quicker, but if you have the problem already calculated, sometimes it helps just to drop your 2 into the problem they give you. F of h of 1. Well, one way we talked about doing is figuring out h of 1. The h function is 1, so we'd square it. Minus 2 times 1 plus 7. So 1 squared minus 2 plus 7. Well, 1 squared is 1, so we don't have to square anymore. Negative 1 plus 7 is 6. Then you take the f function and plug the 6 into the f function, which is 5 times 6 minus 4, which is 30 minus 4, which is 26. And we would get the same result if we took our f of h, which we had here. If we did f of h of 1, 5 times 1 squared minus 10 times 1 plus 31. This is not 5 squared, this is 1 squared. 1 squared times 5 is 5. Times negative, or 10 times 1 is 10, so minus 10 plus 31. That is 26. They are the same. Okay, so what we tried to point out, if you switch the h and the f to do it h and f, you get different equations. So are they the same thing? And we came up with no. Compositions are not the same. Good job, everybody.